Hi everyone. In this video, I want to talk about the beginning of our chapter 3. Chapter 3 is divided into two outcomes. The first is talking about set and set notation. So let's start off with talking about what a set is and how you represent those. So some important terms we need to know is first what a set is. So it's a collection of distinguishable objects. So it's something that you can tell apart. So we can do sets in terms of math. You could talk about it in terms of objects. So I gave a couple of examples of each. So you could do a set of whole numbers. You could do, and then for objects, you could say colors of the rainbow. So to list a set, they use a capital letter that usually represents whatever you're talking about. Then they put an equal sign and then some curly brackets to open up the set. And then you list with commas all the objects inside of the set. And then you close the bracket with a curly, using a curly bracket. And then so for set of colors in a rainbow, R equals, so I open the curly bracket up and I list all the colors of the rainbow and then I close the bracket. So here's an example of objects, so that are colors, and here's an example where you'd have numbers. So the key is that you can tell them apart inside, and that you use a capital letter and the curly brackets to indicate that you have a set. The next example or definition that I want to do is called a finite set. So a finite set is a set that you can count the objects in. So an example would be the colors in the rainbow. We know what they are, we can physically count them. So that would be a finite set. An infinite set, that's the opposite. So this is when you would see no end in sight to what was in your set. So the whole number set that I did in the first example would be an example of that, because we can keep counting on to infinity, starting from 0. So we can't really get a full count on that, so it goes on and on forever. Instead of saying an object in a set, I can now say that that's an element. So an element is an object in the set. If I go back up here to set R, red would be an example of an element in the set. The next definition I want to talk about is called a universal set. So this is a set of all the elements under consideration for a particular context. So it's the wider idea. So basically anything that would belong to a set would belong to also to the universal set. So when giving you an example of a universal set, if I said universal set is numbers, and then my set inside of it would be whole numbers. So when you put a set inside of a set or an object inside of an object, they call that subset, which leads me to my next example. A subset is a set whose elements all belong to another set. So for example, I have two sets here. If I said that set D is 0 to 9 numbers, then all odd numbers would fall into this set. So if I said my second set is set O, which would be 1, 3, 5, 7, and 9. So those are all the odd numbers from 0 to 9. So I could say that O is a subset of D, because all of the elements or objects inside of O also belong to D. This is the notation for a subset. It's a sideways U. So this symbol right here, that is, you would read this as O is a subset of D. And the last definition on this page is called a complement. So a complement in math is all the elements of a universal set that do not belong to a subset of it. So an example of that would be if I go back to my set D where I have 0 to 9, and then I have O, which was all your odd numbers. To do complement, they use an apostrophe up top here. So if I say O apostrophe, that's O complement. So that would be anything that's in the universal set but doesn't belong to O. So anything that is in the universal set but not in O. So things that would be in the set were numbers 0 to 9, but things that aren't in O was odd, so that must be all my even numbers. So 0, 2, 4, 6, and 8 are all elements that do not belong to O, but they belong in the original set D. So complement is kind of something that belongs to one, it's basically what doesn't belong to the set, but not everything else. The next definition I want to talk about is called an empty set. So it's possible to have a set that has no numbers that belong to it. So there's two different types of notation that you could see. You can see curly brackets with nothing in it, or you can see curly brackets with a 0 with a line through it. So both of these two symbols represent that there's no objects inside the set. The last definition I want to talk about is disjoint. So if I say two sets are disjoint, that means that there's nothing in common between the two sets. So if I was talking about people and hamburgers in my two sets and there's nothing in common between the two, then you would say that they were disjoint. Going back to like drawing a Venn diagram, you're familiar with a Venn diagram that overlaps typically, because usually we use a Venn diagram not in math, but in other subjects for similarities and differences. So like say in English, you might have done a Venn diagram where in the middle was everything that was similar or overlapped, and on the outsides were the differences. So if we use this in math, if we draw a Venn diagram with overlap, we're saying that whatever elements are in set A, and whatever elements are in set B are, there's going to be something that's similar. So you're going to have an element that repeats in both sets. So you'd put that in the center. However, if there's nothing common between the people, say, and the animals in set P, if there's nothing in common, then you would draw them as two separate circles where the sets aren't touching, because there's nothing in common. So you'd have nothing repeat inside the brackets when you list your elements. So in this diagram here on the left, A and B are disjoint, and on the right-hand side, there must be something in common because I drew overlap. Looking at example 1, it says indicate the multiples of 5 and 10 from 1 to 500 using set notation. List any subsets and then diagram the sets. So whenever you do this, you have to talk about the universal set. So that's like the wider, bigger picture of what everything else belongs into. So for our particular example, I used, and you get to pick what letter you want, I used S for the universal set. Sometimes they use U for universal, but I used S. And I just said, and in words, it's okay to describe in words as well, what my universal set is. So my universal set in this example would be all numbers from 1 to 500, because those are the restrictions the question gave me. Then to show it with set notation, I don't want to physically list every single number from 1 to 500. That would take a really long time. So if I use greater than or less than symbols, I can state that. So here's some fancy notation. So basically what I'm saying in this second line here is that the universal set S, and I'm going to say X, I'm just going to choose a variable. So X such that X is in between 1 and 500, and X is exists in the natural numbers. So basically it's between 0 and higher. So natural numbers are 0 and higher. But here, this is the main part of this, is I'm saying any number that I pick, X, is in between 1 and 500. I can do this instead of writing out 1, 2, 3, all the way to 500. So I can shorten it this way and just say, choose any number x such that x is in between 1 and 500. Now it asks me for the multiples of 5 and the multiples of 10. So a multiple of 5 means that the number is divisible by 5. So you're basically counting by 5s. So I have to make a new set. So this set F, I'm going to talk about that for multiples of 5, exists in the universal set S. So I'm going to write in words what F is. So it's all multiples of 5 from 1 to 500. As numbers, 5, 10, 15, 20, 25, and so on. Again, I don't want to have to write all those out. That would be very time consuming. So if I use x again, how you write a multiple of 5, you go 5 multiplied by a variable. So 5x would be an example of a multiple of 5. And then now my restriction that I'm going to choose for my x's will be x can be anywhere between 1 and 100. Because if I sub in a 1 here for x, 5 times 1 is 5. And if I sub in 100 here for x, 5 times 100 is 500. So therefore, by using the shorthand notation, I've covered all multiples of 5 between 1 and 500 by just using this notation. Because all of those numbers, 5, 10, 15, 20, and so on, are also in between 1 and 500, I can say that F is a subset. This is the abbreviation for subset, or symbol, I should say. F is a subset of our universal set S. And finally, it asked about multiples of 10, so I have to create another set. So I'm going to call it T for multiples of 10. In words, I would say any multiple of 10. Here, I'd go 10, 20, 30, 40, 50, all the way till I got to 500, and then I would stop. But I don't want to write them all out. So again, if I write 10x, that's saying multiples of 10. And then again, it would just have to be between 1 and 50 would be my x's that I could put in there, because that would give me all of my numbers from 10 to 500 this way. Because if I sub in a 1 there, I get 10. If I sub a 50 in, I get 500. So if I choose values between 1 and 50, I will get all of those ones. And this is simpler than writing it all out by hand. I can also say that all multiples of 10, I know they belong in the universal set S because they're numbers from 1 to 500, but they also belong into the multiple of 5 set, because 10, 20, 30, you can divide all those by 5. So they're also multiples of 5. So multiples of 10 are multiples of 5. So I would say 10, or set T, is a subset of set F, and then it's also a subset of S. So how I would draw a Venn diagram of this, if you see over to the right, there's my universal set. It always goes in the corner of my box, saying here, this is all my objects inside of the universal set S. Then, because I know T is a subset of F, I put the circle inside of F. So you always read from the center of these Venn diagrams. I would say T belongs to F. So I put T inside of it. Then I have F prime, or F complement. So this would be all the other numbers from 1 to 500 that are not multiples of 5 or 10. So like, for example, 4 or 2. All of those numbers still belong in the universal set from 1 to 500, but they are not part of T or F because they are not a multiple of 5 or 10. So I would define F complement, or F prime, as all my non-multiples of 5. Lastly, say someone might ask, what about 501, the number 501? Well, it would be outside of my Venn diagram and outside of my universal box, because I said the universe was numbers 1 to 500. So the numbers like 501 wouldn't exist. It would be outside of this. It'd be an empty set type of idea. Ignore this for right now. I'll get to that in a bit. You now should be able to work on Bellwork 3.1 that's in Microsoft Teams in the Files section.